they're really not too difficult in terms of actually solving, because it's saying solve each equation. That part is fine. The second part where it says be able to justify each step with a property of equality, that's where we would run into a little bit of trouble. All right. So, but if I tell you that a property of equality is really just anything that you can do to both sides of the equation that's legitimate, then that should help a little bit. So, for example, you can multiply both sides of an equation by a number. You can divide both sides of an equation by a number. You can add a number to both sides of an equation. You can subtract a number from both sides of an equation. You could raise both sides of an equation to a power. You can take a root of both sides of an equation. These are some things that you can do. As long as you do them to both sides of the equation, you're fine. All right. Well, what they're asking us to do here is justify by indicating what that step is after you do it, which isn't really the best thing in the world, because it's kind of, I think anyway, it's kind of obvious when you're multiplying both sides by a number, you're applying the multiplication property of equality. How do we know? Because you just multiplied both sides of the equation. Okay? If you're dividing both sides of the equation by 2, you're using the division property of equality. It's as simple as that. All right? So looking at number 5 here, bless you. So looking at number 5, the first thing I would look to do is isolate the 2y minus 10. I would do that by multiplying both sides by 5. There's other things you could do if you want. You could divide both sides by 1/5. That would make things a little bit more complicated, I think. But what these instructions are telling us to do is then state that we are using the multiplication property of equality. All right, we could abbreviate that. All right, we're only doing this because that's what they're going to ask you to do on the Regents exam. This part, anyway. Solving equations, that's valuable. We need to know how to do that. But making this statement that's telling everybody what they already knew, that doesn't really add anything to the conversation. All right, except to say, well, we want full credit when we do this on a Regents exam, so here we are. All right, so I would cancel the 5s because 5 divided by 5 goes to 1. 2y minus 10 would be equal to 40. All right. So then I want to get the 2y alone. All right. I want to isolate this. The way I would handle that is by getting rid of the negative 10. I would do that by adding a 10 to both sides. That would be the addition property of equality. All right. Which would give you a result of 2y equal to 50. So if I want to get y alone, finally, I would divide both sides by 2, utilizing the division property of equality. If this feels incredibly pointless to you, all this stuff here, don't worry, it feels incredibly pointless to me also. All right. It is what it is. We got to do it to get full credit. So that's sometimes the nature of the beast. All right. So we would get y is equal to 25. And that would be it. That would be the solution. I think the main focus should be on all this stuff. But they seem to be interested in your ability to write the word multiplication in addition to actually carrying out the operation of multiplication. I don't know why. All right. So number 6, we'll just do one more. Number 6, we have a little distributive property. So we could get started with that if we want. You know, we could run through with a 4. We could also look at it from a different perspective and say, all right, well, I want to get rid of everything but the d, so maybe I'll get rid of that 4 first. You know, there's different avenues. You could go different routes. It's really up to you. As long as you're following a legitimate method, you're not going to be wrong, even if that method isn't the same first step that I would do, or it doesn't have the same first step that I would have. So I'm going to subtract a 4 from both sides, utilizing the subtraction property of equality. So if it feels like you're just taking the word that represents the thing that you're doing and slapping on a POE at the end, then you got the idea. All right? So we would have 4 is equal to 4 times d minus 2. I want to get rid of the 4, the coefficient of 4. So I'll divide, division, property of equality. So I'd have 1 is equal to d minus 2. To get d alone, I would add 2 to both sides. And that would be my addition, property of equality. All right, so 3 is equal to d, and that would be your solution. Now, I did want to take a minute to show you how you could do this on Desmos, not the algebra, but at least arrive at the answer. Because some of these equations get fairly complicated, and especially when it involves distributive property, sometimes you find yourself making a mistake only because maybe you forget to distribute a negative or something like that. So I wanted to show you how to tackle a problem like this on Desmos. So the first thing you would do is rewrite the equation just using x's instead of whatever variable they threw in there. Most of the time the problem you're given will have an x in it anyway, but sometimes it won't, and if it doesn't, then we write it in terms of x. So I don't know why I wrote a d there. So 4 times x minus 2 plus 4. Now in Desmos, it's actually fairly straightforward. This is one of the easier things that you can do in Desmos. The first thing you would do is write an equation where y is equal to the left side of your given equation. All right? So you would write y equals 8. I'm going to bring it in a little bit. So whatever the left side is in the given equation, you're going to write y equals that in Desmos. So I'll do it as we go. So y equals 8. Very simple. Then you're going to write y equals whatever the right-hand side of the equation is, without making any algebraic adjustments. So leave it as is. So 4 parentheses x minus 2 plus 4. So y equals 4 parentheses x minus 2 plus 4. All right? Then you're going to find the x value of the intersection. All right, you're going to find the x value of the intersection. So if you look at the Desmos screen, you see only one line. There should be 2 lines, which means that our zoom isn't perfect. So what I'll do is I'll hit the little home icon. It'll zoom out a little bit to negative 10 to 10 window. I could zoom out a little further to make it look a little nicer. You see that there's a coordinate where the 2 graphs cross, where the blue line crosses with the red line. Tap on that intersection and a gray dot will appear. Tap on that gray dot and a coordinate will appear. The x value of that coordinate would be the solution to the equation. All right? So you'd look at this and say, well, that's kind of complicated. But then you kind of look at it and say, well, it's all relative to whatever the equation is that you're given. If it's an easy equation, something that's very easy to do by hand, then yeah, it's probably overly complicated to use Desmos. But if you're looking at a nasty equation, or even better, you're taking a test and it's a multiple choice question where you don't have to show any work, Desmos will do it all for you without you really having to think too much. All right. So that's sometimes a good thing. So looking back at number 5, maybe you just don't like fractions. All right. Looking back at number 5, you can take the left-hand side of the equation, write it as y equals. Now, the thing you got to be careful about is the original equation, I'll write it out. The original equation has to be written with an x in it. So you'll get to a point where you won't actually be writing it just like I am here. You'll just be thinking about it as if it were an x. But then you'll write y equals, in Desmos, you'll write y equals 2x minus 10 over 5. and y equals 8. And you'll see where those two things cross. So y equals, I'll put the fraction in first, type in 2x minus 5, 2x minus 10 over 5, and then y equals 8. I don't see a defined intersection on my screen here, but if I zoom out, there will be one. Tap on that intersection to show the gray dot. Tap on the gray dot to show the solution. The x value is your solution. All right, 25, just like we got algebraically. All right. So the Desmos approach, again, is very useful if you don't have to show any work. So use it. You know, you'll find in the beginning of the course, I find that students are often resistant. They're like, I don't like this. It's different technology. I don't want to use it. But as time goes on, they start, becoming more open to using the technology. So, as you get more and more comfortable, try to do more and more things in Desmos and see how it goes. Right? And if you have any questions, you let me know.